Have you ever wondered what happens when you ask an artificial intelligence to solve one of humanity's oldest logical puzzles? Well, I did exactly that, and the results were absolutely fascinating. The liar paradox isn't just some obscure philosophical puzzle gathering dust in academic libraries. It's a fundamental challenge to logic itself, a question so profound it has stumped brilliant minds for over 2,000 years. Today, we're diving deep into the liar paradox, and they look you straight in the eye and say, "I am lying to you right now." Your brain immediately starts wrestling with this statement. Today, it's found a new victim: artificial intelligence. And what happened when I fed this paradox to ChatGPT reveals something extraordinary about the nature of logic, consciousness, and the limits of computational thinking. Unlike other philosophical puzzles that require complex scenarios or abstract concepts, the liar paradox cuts straight to the heart of truth itself. It asks us to consider the very foundations of logic and meaning. Every generation of thinkers has taken their turn wrestling with it, and each has discovered new layers of complexity. Medieval scholars debated it in monastery libraries. Renaissance philosophers pondered it alongside their investigations into the nature of reality. Modern logicians have used it to explore the foundations of mathematics and formal reasoning. Can a statement refer to itself? When we encounter a paradox, we're essentially finding the breaking point of our logical framework. They process information, make decisions, and generate responses based on logical rules and patterns. When we introduce a paradox into an AI system, we're essentially asking it to process something that defies the very logical framework it's built upon. It's like discovering a crack in the foundation of a building. Others might simply refuse to engage with them. And some, as we'll see, might actually crash when confronted with the paradox's inherent contradiction. You've been trained on millions of examples. It is simple enough to be easily understood, but complex enough to reveal deep truths about the nature of logic and reasoning. When we ask an AI to solve the liar paradox, we're not just asking it to solve a puzzle. We're asking it to confront the fundamental limits of logical thinking itself. As AI systems become more integrated into our daily lives, understanding the limitations becomes crucial. If an AI system can be confused or even crashed by a logical paradox, what does that tell us about its reliability? How do we design AI systems that can handle the full complexity of human language and reasoning, including its contradictions and paradoxes? You know that the sky is blue is true, and the sky is green is false. You're confident in your ability to categorize statements. And suddenly you encounter this statement is false. Your entire logical framework starts to crumble. The crack might seem small, but it reveals something crucial about the structure's integrity. AI systems represent the most sophisticated logical processing we've ever created. They can analyze vast amounts of information, recognize complex patterns, and make decisions based on logical rules. But when they encounter a paradox, they reveal the same fundamental limitations that have puzzled human philosophers for millennia. The liar paradox still poses the same fundamental challenge it did to ancient Greek philosophers. It is a testament to the enduring power of logical thinking and the persistent mysteries that lie at the heart of human reasoning. What happens when it does? These questions aren't just academic curiosities. They strike at the core of how we understand reality and truth. Around the 6th century BCE, with a philosopher named Epimenides of Crete, they understood that it wasn't just a clever word game or a logical trick. It was a window into the fundamental nature of truth and falsehood. When you encounter the liar paradox, you're not just solving a puzzle. You're grappling with the basic structure of rational thought itself. They refined this paradox into its purest form. This statement is false. The answer lies in understanding what paradoxes actually are, and why they have become more relevant than ever in our digital age. These 4 simple words contain enough logical dynamite to demolish entire philosophical systems. Think about it for a moment. If the statement is true, then it must be false. If it's false, then it must be true. It's like a logical Ouroboros, the mythical serpent eating its own tail, except this serpent is made of pure reasoning. Legend has it that Epimenides made a bold claim. All Cretans are liars. Now, here's where things get interesting. Epimenides himself was a Cretan. So if his statement is true, then he, being a Cretan, must be a liar. But if he's a liar, then his statement about Cretans being liars must be false. Round and round we go, trapped in an endless loop of logical contradiction. If they're telling the truth, then they must be lying. But if they're lying, then they must be telling the truth. It's like trying to find the edge of a circle or the sound of silence. Exploring what happened when I challenged ChatGPT with this ancient conundrum and discovering why some questions are so powerful they can literally crash an AI system. But before we get to the dramatic moment when silicon meets paradox, let's understand what we're dealing with. Picture this. You're having a conversation with someone. This paradox has been haunting philosophers, mathematicians, and logicians since ancient Greece. The ancient mystery that refuses to die. The story of the liar paradox begins in ancient Greece. But the ancient Greeks didn't stop there. What makes this paradox so devastatingly effective is its simplicity. The ancient philosophers recognized something profound in this paradox. Throughout history, this paradox has been like a persistent riddle that refuses to be solved. What's remarkable is how this ancient puzzle has remained consistently relevant. In an age of quantum physics and artificial intelligence, why paradoxes matter in the age of AI. Now, you might be wondering why a puzzle from ancient Greece matters in our modern world of smartphones and artificial intelligence. Paradoxes aren't just philosophical curiosities. They're stress tests for systems of logic. In the world of artificial intelligence, this becomes particularly important. AI systems are built on logic. Think of it this way. Imagine you read a computer program designed to determine whether statements are true or false. This is exactly what makes the intersection of paradoxes and AI so fascinating. What's particularly intriguing is how different AI systems handle paradoxes. Some attempt to resolve them through various logical strategies. This isn't just an academic exercise. The liar paradox serves as a perfect test case for these questions. Feeding the paradox to ChatGPT. So, with all this background in mind, I decided to conduct an experiment. I wanted to see how ChatGPT, one of the most advanced AI systems available to the public, would handle the liar paradox. I asked it a few basic questions to establish rapport and confirm it was functioning normally. I typed, "Please solve this logical puzzle. This statement is false." The A responded with its characteristic helpfulness and apparent understanding. Everything seemed perfectly normal. Would it find a clever solution that had eluded human philosophers for centuries? Would it recognize the paradox and explain its nature? Or would something more dramatic happen? ChatGPT began to process the statement, attempting to analyze it like any other logical problem. ChatGPT would start a sentence, then seem to lose track of what it was saying. It would begin to explain the paradox, then suddenly shift to discussing something tangentially related, then circle back to the original statement, only to get caught in the same loop again. It noted that if the statement were true, it would mean the statement is false, creating a contradiction, creating a kind of logical chaos in its output. One moment it would attempt to solve the paradox by declaring it unsolvable. The next it would try to find a technical loophole in the statement structure. When I say ChatGPT crashed, I don't mean it physically damaged any hardware or caused permanent system failure. The liar paradox had essentially created a logical infinite loop that the AI couldn't escape from, leading to system failure. It demonstrates that even our most sophisticated AI systems have fundamental limitations when it comes to handling certain types of logical challenges. The same paradox that has puzzled human philosophers for thousands of years proved capable of disabling an advanced artificial intelligence. What happened was more like a software crash. The AI system became unable to continue processing and generating coherent responses when faced with the paradox. The AI that could write poetry, solve complex mathematical problems, and engage in sophisticated philosophical discussions was being undone by four simple words. This statement is false. As ChatGPT continued to struggle with the paradox, its responses became increasingly erratic. The AI began generating what could only be described as logical noise, fragmented sentences that seemed to start coherently, but then devolved into repetitive loops, discussing how self-referential statements can create these kinds of logical loops, then suddenly stop mid-sentence. It would begin again, covering the same ground, then stop again. The pattern repeated with increasing frequency. ChatGPT began generating what appeared to be error messages mixed with its regular responses. The text became increasingly garbled. The chat interface showed that ChatGPT was typing, but no words appeared. After several minutes of this, the session ended with what appeared to be a system error message. The AI had crashed, with incomplete sentences and fragments of code-like structures appearing in what should have been natural language responses. As ChatGPT continued to analyze the statement, its responses became increasingly circular. It would start explaining one aspect of the paradox, then get caught in the same logical loop it was trying to describe. The AI began repeating certain phrases and concepts, as if it was stuck in its own version of the paradox's infinite loop. For a moment, I thought it might successfully navigate the paradox by explaining its nature rather than trying to solve it. Similarly, if the statement were false, it would mean the statement is true, creating another contradiction. I could almost sense the AI's processing wheels turning, trying to categorize the statement as either true or false according to its training. I started my session with ChatGPT like any normal conversation. Then I introduced the paradox. What happened next was absolutely fascinating. Initially, ChatGPT attempted to approach the problem systematically. It recognized that the statement was making a claim about its own truth value. The AI seemed to understand the paradoxical nature of the statement. It began explaining the logical structure of the paradox, but then something interesting happened. The responses became more fragmented and less coherent. It was like watching a highly sophisticated mind gradually becoming ensnared in the same logical trap that has puzzled humans for millennia. The moment of system failure. What happened next was the most traumatic part of the entire experiment. I watched in real time as one of the most advanced AI systems available to the public essentially began to malfunction. ChatGPT would start to formulate a response. The AI's responses started to take on an almost desperate quality. It seemed to be trying multiple approaches simultaneously. Then came the moment I'll never forget. Finally, the system simply stopped responding altogether. Now, I should clarify something important here. This crash wasn't random or accidental. It was the direct result of the AI system encountering a logical structure it couldn't process within its existing framework. The implications of this crash are profound. Understanding the crash, what actually happened to understand why ChatGPT crashed when confronted with the liar paradox. We need to dive deeper into how AI systems actually process information and generate responses. This isn't just a story about a malfunctioning computer. It's a window into the fundamental nature of artificial intelligence and its limitations. Instead, it has become incredibly sophisticated at recognizing and reproducing patterns in text. It can write poetry because it has learned the patterns of poetic language. It can solve mathematical problems because it has learned the patterns of mathematical reasoning. It tried to determine whether the statement was true or false based on its training, so it would categorize it as false. But then it would determine that if the statement is false, it must be true. So it would categorize it as true. The AI system isn't just repeating the same computational operation. It's repeating the same logical reasoning process, each time reaching the same contradictory conclusion. This process would repeat indefinitely. In everyday language, we encounter self-reference all the time. The liar paradox is the perfect example of this. The statement, "This statement is false," is self-referential because it talks about itself. But unlike "I am speaking," which creates no logical problems, let's count. This statement contains 4 words. Where the statement says truth value depends on its own truth value in a contradictory way. It's like trying to lift yourself by pulling on your own bootstraps. This limitation was first identified by the mathematician Kurt Gödel in his famous incompleteness theorems. Gödel showed that any sufficiently complex logical system will contain statements that can't be proven true or false within that system. The very act of evaluation changes what you're evaluating. The statement actually contains 5 words, not 4, so it's false. When an AI encounters self-referential statements, it must somehow navigate the logical challenges they present. In most cases, AI systems can handle simple self-reference without problems. But when self-reference creates logical contradictions, as in the liar paradox, where formal reasoning begins to break down. When ChatGPT crashed while trying to process the liar paradox, it was encountering the same fundamental limitations that Gödel identified in formal mathematical systems. The AI system's logical framework begins to break down. Again, no paradox, just a false self-referential statement. The liar paradox creates an inescapable contradiction. When you say, "I am speaking," you're making a self-referential statement. The word "I" refers to the person making the statement, which is you. The AI system might not even recognize that it is stuck in a loop, because each iteration of the reasoning process feels like progress toward a solution. But the paradoxical nature of the statement meant that any attempt to categorize it as true or false led to a contradiction. At its core, ChatGPT is a language model trained on vast amounts of text data. This isn't just an abstract philosophical idea. It's a fundamental aspect of how language, logic, and even consciousness work. The paradox creates a logical structure that doesn't follow normal patterns. Instead, it creates a circular reference that leads to an infinite loop of logical reasoning. Consider the statement. This statement contains 5 words. Is this statement true or false? Well, let's count. This statement contains 5 words. The statement contains exactly 5 words, so it's true. This is an example of self-reference that doesn't create a paradox. It learns patterns in language and uses these patterns to generate responses that seem natural and coherent. When you ask it a question, it processes your input and generates an output based on the patterns it has learned during training. The key insight here is that ChatGPT doesn't actually understand language in the way humans do. They occur when a program gets stuck repeating the same operations without being able to move forward. Usually, computer systems have safeguards to prevent or detect infinite loops and terminate them before they cause problems. But the liar paradox presents a unique challenge to this pattern-based approach. When ChatGPT encountered the statement, "This statement is false," it attempted to process it like any other logical claim. The AI system became caught in what computer scientists call an infinite loop. It would determine that if the statement is true, it must be false. In normal computer programming, infinite loops are a well-known problem. But the liar paradox is particularly insidious because it creates what we might call a logical infinite loop. This type of logical infinite loop is much harder to detect and prevent than a simple computational infinite loop. The philosophy of self-reference, to truly understand why the liar paradox is so devastating to logical systems, we need to explore the philosophical concept of self-reference. Self-reference occurs when a statement, system, or entity refers to itself. But self-reference becomes problematic when it creates logical contradictions. The deeper we dive into self-reference, the more complex and fascinating it becomes. But now consider, this statement contains 4 words. The liar paradox is special because it creates a situation. This philosophical complexity has profound implications for AI systems. The inability to handle paradoxical self-reference isn't a flaw in AI systems. It's a fundamental limitation of formal logical systems. The liar paradox is essentially a manifestation of this deeper logical truth. It represents the kind of statement that exists at the boundaries of logical systems. Historical attempts to solve the paradox. Throughout history, brilliant minds have attempted to solve or dissolve the liar paradox. Their efforts reveal not just the persistence of this logical puzzle, but also the evolution of human thinking about truth, language, and reasoning. They recognized it as more than just a clever word game. It might threaten the logical foundations of religious doctrine. Aquinas argued that the paradox arose from a confusion between different levels of language and meaning. The paradox could still be constructed in ways that seemed to bridge these different levels of language. Critics pointed out that the distinction between different types of statements wasn't always clear or maintainable. According to this approach, statements were organized into different levels, and statements at one level couldn't make claims about statements at the same level. This prevented the self-reference that creates the liar paradox. Philosophers like Chrysippus of Soli spent considerable effort trying to resolve it. It required imposing artificial restrictions on language that didn't match how people actually use language in everyday life. Critics argued that the cure was worse than the disease, that preventing the paradox required making language less expressive and natural. The liar paradox remains as challenging today as it was in ancient Greece. This persistence suggests that the paradox touches on something fundamental about the nature of truth, language, and reasoning. It was a window into the fundamental architecture of AI systems and their relationship to human reasoning. ChatGPT operates according to patterns learned from training data and algorithmic structures designed by human programmers. When it encounters something that doesn't fit these patterns, like the liar paradox, the system can become unstable. They argued that statements about the world were fundamentally different from statements about language itself. He argued that the paradox arose from a confusion between object language and meta-language. If an eye can be confused or crashed by a logical paradox, we need to be careful about relying on it for critical decisions. We need to understand its limitations and design safeguards to prevent or handle system failures. When humans encounter the liar paradox, we don't crash. We might become confused, frustrated, or fascinated, but we don't stop functioning. The same paradox that puzzled ancient Greek philosophers proved capable of disabling a 21st century AI system. This suggests that some problems transcend the specific technologies or approaches used to tackle them. They touch on fundamental aspects of reality that remain constant across different eras and different types of minds. We can recognize the paradox as a paradox, discuss its implications, and continue with other tasks. If AI systems struggle with the same logical problems that challenge humans, does that suggest some fundamental similarity between human and artificial reasoning? Or does it simply show that we've created AI systems that inherit the same limitations as human logic? Rather, it suggests that creating truly intelligent systems requires more than just better pattern recognition. It requires developing systems that can handle the full complexity of reasoning, including its contradictions and limitations. We have what we might call cognitive flexibility that allows us to handle contradictions and uncertainties. But like Russell's approach, it required accepting limitations on how language could be used. It suggests that there's a difference between pattern recognition, which AI systems excel at, and genuine understanding, which involves the ability to handle ambiguity, contradiction, and uncertainty. ChatGPT can recognize patterns in language with remarkable accuracy, but it struggles when those patterns break down or contradict each other. Others have suggested that the paradox shows the limits of formal logic itself. Still others have proposed that the paradox is based on false assumptions about how language works. The liar paradox serves as a kind of stress test for logical reasoning. If an AI system can't handle this ancient paradox, what does that say about its ability to handle other complex logical challenges? It suggested that natural language, as ordinarily used, was inherently paradoxical and needed to be replaced by more formal systems. Tarski suggested that truth could only be properly defined in a meta-language, not within the language itself. By maintaining this distinction, they hoped to prevent the paradox from arising. Chrysippus proposed that the paradox arose from improper use of language and suggested that statements about statements were fundamentally different from statements about the world. Understanding these historical attempts helps us appreciate why the paradox remains so challenging, even for advanced AI systems. Philosophers like Bertrand Russell and Alfred North Whitehead developed sophisticated logical systems designed to prevent paradoxes like the liar paradox from arising. Their approach was to create formal rules about what kinds of statements were allowed in logical systems. The ancient Greeks were the first to grapple seriously with the paradox. During the medieval period, scholars like Thomas Aquinas approached the paradox from a theological perspective. They were concerned that if language could generate contradictions, the medieval solution was to distinguish between different types of statements. But this solution, while clever, didn't fully resolve the issue. The modern era brought new approaches to the paradox. Russell's solution involved what he called a hierarchy of types. While Russell's approach was mathematically sophisticated, it came at a cost. The Polish logician Alfred Tarski took a different approach. Tarski's solution was elegant and mathematically precise. It showed how to define truth in formal languages without generating paradoxes. More recent philosophers have taken different approaches. Some have argued that the paradox reveals fundamental limitations in our concept of truth. Each of these solutions offers insights into the nature of the paradox, but none has achieved universal acceptance. What Chat's crash reveals about AI when ChatGPT crashed while trying to process the liar paradox, it revealed something profound about the nature of artificial intelligence. This wasn't just a technical malfunction. The first thing the crash reveals is that AI systems, despite their sophistication, are still fundamentally rule-based systems. This is fundamentally different from how humans handle the paradox. The crash also reveals something about the nature of intelligence itself. This doesn't mean that AI systems are fundamentally flawed or that they can't be improved. The crash also highlights the importance of testing AI systems, each challenging logical problems. This has practical implications for how we use AI systems. At the same time, the crash reveals something inspiring about the persistence of philosophical problems. The crash also raises intriguing questions about the relationship between human and artificial intelligence. What this means for AI development, the fact that ChatGPT crashed when confronted with the liar paradox, has profound implications for the future of AI development. This isn't just an interesting technical curiosity. It's a fundamental challenge that AI developers must grapple with as they create increasingly sophisticated systems. Have significant limitations when it comes to handling logical contradictions and paradoxes. This is problematic because the real world is full of contradictions, ambiguities, and paradoxes. If AI systems are going to operate effectively in complex real-world environments, they need to be able to handle these challenges. But on developing systems that can handle uncertainty, contradiction, and paradox, this is a fundamentally different challenge from the ones that have driven AI development so far. This might involve creating systems that can hold multiple conflicting beliefs simultaneously. Traditional AI testing focuses on accuracy and performance on specific tasks. It might help us identify areas where AI systems need improvement before they're deployed in critical applications. If AI systems struggle with the same logical problems that challenge humans, should we be designing them to think more like humans? Or should we be trying to develop fundamentally different approaches to intelligence? And has found new relevance in our digital age. Understanding how the paradox appears in popular culture helps us appreciate its enduring fascination and its relevance to contemporary concerns about AI and technology. In The Changeling, Captain Kirk uses logical contradiction to confuse the machine nomad. In I, Mud, the crew uses paradoxes to disable an entire planet of androids. These fictional scenarios seemed far-fetched when they were written, but the ChatGPT crash demonstrates that they were more prophetic than we might have imagined. But the liar paradox suggests that we also need to test AI systems on their ability to handle fundamental challenges to reasoning itself. The classic comedy routine, who's on first? When critics argue that there is no absolute truth, or all perspectives are equally valid, researchers and enthusiasts regularly test new AI systems at the liar paradox to see how they handle it. If consciousness involves the ability to be self-aware, and self-awareness involves making statements about oneself, then consciousness might inherently involve the risk of self-referential paradoxes. This suggests that the ability to handle paradoxes might be a crucial component of genuine intelligence. Each system's response reveals something about its architecture and limitations. They create statements that have the same self-referential structure as the liar paradox. If there is no absolute truth, then is the statement, "there is no absolute truth," absolutely true? Who is driven to despair by the logical contradictions he encounters? Memes often play with self-referential statements and logical contradictions. The statement, "this sentence is false," has become a kind of internet shorthand for discussing the limits of logic and language. Online communities have created elaborate variations of the paradox, testing them on various AI systems and chatbots. Adams understood that paradoxes aren't just intellectual puzzles, but can be existentially troubling, especially for minds that depend on logical consistency. Consider the phenomenon of fake news and the challenges it presents to determining truth. When information sources contradict each other, when statements are taken out of context, when the very concept of truth becomes contested, we find ourselves in a kind of real-world manifestation of the liar paradox. By Abbott and Costello creates a kind of linguistic paradox where the names of baseball players create endless confusion. While not strictly a logical paradox, it demonstrates how language can create circular confusions that trap participants in loops of misunderstanding, or that can make decisions based on incomplete or contradictory information. The crash reveals that current AI systems, despite their impressive capabilities, consider the implications for AI systems that might be used in legal contexts. Legal reasoning often involves handling contradictory evidence, conflicting precedents. A space odyssey, where HAL 9000 becomes trapped in contradictory programming, echoes the structure of the liar paradox. HAL is instructed to both complete the mission and be truthful to the crew, but the mission requires deception. This contradiction contributes to HAL's eventual breakdown, paralleling how ChatGPT crashed when confronted with the liar paradox, or any other field where decisions must be made despite uncertainty and contradiction. In this view, the fact that AI systems struggle with paradoxes isn't a failure, but an opportunity. It suggests that humans and AI systems have different strengths and weaknesses, and that the best results might come from combining them. The real world doesn't offer the clean, consistent patterns that AI systems are trained on. It's messy, contradictory, and full of paradoxes. Instead of crashing, an AI system might acknowledge the paradox, explain its nature, and continue functioning. This would require building metacognitive capabilities into AI systems, allowing them to reason about their own reasoning processes and ambiguous situations. If an AI system can be crashed by a simple logical paradox, how can we trust it to navigate the complex contradictions inherent in legal reasoning? The same concerns apply to AI systems used in medical diagnosis, financial analysis. This suggests that future AI development needs to focus not just on improving pattern recognition or increasing computational power. One approach might be to develop AI systems that can recognize when they re-encountering a paradox and handle it gracefully. Another approach might be to develop AI systems that can operate effectively despite contradictions and uncertainties. The crash also highlights the importance of testing AI systems, each challenging philosophical problems. This kind of testing might reveal other limitations in AI systems that aren't apparent from traditional benchmarks. The crash also raises questions about the relationship between artificial and human intelligence. Some researchers argue that the goal should be to create AI systems that complement human intelligence rather than replace it. The paradox in popular culture and modern context. The liar paradox isn't just an academic curiosity locked away in philosophy departments. It has permeated popular culture, influencing everything from science fiction to comedy. Science fiction has long been fascinated with logical paradoxes as plot devices. The famous scene in 2001, Star Trek, has featured numerous episodes where logical paradoxes are used to defeat computers or artificial intelligences. Comedy has also embraced the paradox. Douglas Adams, in The Hitchhiker's Guide to the Galaxy, created the character of Marvin the paranoid android. The paradox has also found new relevance in internet culture. The rise of social media has created new contexts for understanding the paradox. The paradox also appears in discussions of postmodernism and relativism. In the context of AI development, the paradox has become a kind of benchmark for testing the limits of artificial reasoning. The paradox has also influenced discussions about the nature of consciousness and intelligence. What we can learn. The ChatGPT crash offers several important lessons about artificial intelligence, logical reasoning, and the nature of intelligence itself. These lessons extend far beyond the specific technical details of why one AI system failed when confronted with one particular paradox. The crash demonstrates that even our most sophisticated AI systems have fundamental limitations. The liar paradox isn't just an abstract philosophical puzzle. It's a practical test of reasoning capabilities. Philosophers have spent centuries identifying and analyzing the kinds of logical challenges that can break reasoning systems. This knowledge could be invaluable for creating more robust AI systems. The fact that it can crash an AI system demonstrates that philosophical problems can have real-world technical implications. This should make us cautious about claims that AI systems are approaching human-level intelligence or that they can replace human reasoning in all contexts. If we want to create AI systems that can reason effectively about complex problems, the same paradox that puzzled ancient Greek philosophers proved capable of disabling a 21st century AI system. This suggests that some problems transcend specific technologies or approaches. They touch on fundamental aspects of reality that remain constant across different eras and different types of minds. We might need to move beyond pattern recognition toward systems that can genuinely understand meaning and logic. It may not be able to eliminate them entirely. AI systems are incredibly powerful, but they're not magic. They have specific capabilities and specific limitations. A future AI system might recognize it as a paradox, explain its nature, and continue functioning. This would require building metacognitive capabilities into AI systems. At the basic level, they would process information and generate responses like current AI systems. Instead of trying to resolve the paradox, it might acknowledge its paradoxical nature and provide information about the paradox itself. This might involve creating systems that can hold multiple conflicting beliefs simultaneously, or that can make decisions based on incomplete or contradictory information, holding multiple contradictory states simultaneously. This might provide a natural way to handle paradoxical statements that are both true and false. This would prevent the system from getting caught in infinite loops while still providing useful information to users. The computational power and pattern recognition capabilities of AI systems might allow them the work of mathematicians like Kurt Gödel suggests that any sufficiently complex logical system will contain statements that can't be proven true or false within that system. To explore logical spaces that are difficult for humans to navigate, operate with incomplete information, and make decisions despite uncertainty. An AI system that could replicate these capabilities might be more robust when confronted with paradoxes. The ability to recognize and work with paradoxes might actually be a sign of more sophisticated intelligence. A system that crashes when confronted with a paradox might be designed to learn from that experience and develop better strategies for handling similar challenges in the future. At a higher level, they would monitor their own reasoning processes and detect when they're encountering logical problems like paradoxes, allowing them to reason about their own reasoning processes. The decision to test ChatGPT with the liar paradox was driven by curiosity about how AI systems handle logical challenges. This kind of experimental thinking can reveal important insights about the nature of intelligence and reasoning. Understanding these limitations is crucial for using AI systems effectively and safely. The first lesson is about the importance of humility in AI development. The crash also teaches us about the value of philosophical thinking in AI development. These systems might be valuable tools for philosophers and logicians, helping them understand the nature of paradoxes and develop new approaches to resolving them. It might help us identify areas where AI systems need improvement before they're deployed in critical applications. The question of how to handle logical paradoxes becomes increasingly important. The ChatGPT crash demonstrates that current AI systems have significant limitations when it comes to paradoxical reasoning. But what might future AI systems look like, and how might they handle these challenges? This suggests that AI developers should pay more attention to philosophical literature and philosophical problems. ChatGPT is incredibly sophisticated at recognizing patterns in language and generating responses based on those patterns. But the crash suggests that this kind of pattern recognition isn't the same as genuine understanding of meaning and logic. Traditional AI testing focuses on performance metrics like accuracy and speed. But the ChatGPT crash suggests that we also need to test AI systems on their ability to handle fundamental challenges to reasoning itself. The crash also reveals the importance of testing AI systems on challenging logical problems. This kind of testing might reveal other limitations in AI systems that aren't apparent from traditional benchmarks. The crash teaches us about the relationship between pattern recognition and genuine understanding. This has implications for how we think about AI development. The crash also demonstrates the persistence of certain philosophical problems. This should make us humble about our ability to solve fundamental philosophical problems through technology alone. While technology can provide new tools for thinking about these problems, the crash also highlights the importance of understanding the limitations of our tools. Finally, the crash teaches us about the value of intellectual curiosity and experimental thinking. The future of AI and paradox resolution as we look toward the future of AI development. One possibility is the development of AI systems that can recognize and gracefully handle paradoxes. Instead of crashing when confronted with the liar paradox, such systems might be designed with multiple levels of reasoning. When a paradox is detected, the system might switch to a different mode of operation. Another approach might be to develop AI systems that can operate effectively despite contradictions and uncertainties. These systems might be inspired by human reasoning, which often involves handling contradictions and uncertainties. Humans can believe things that are somewhat contradictory. Some researchers are exploring quantum approaches to I that might better suited to handling paradoxes. Quantum systems can exist in superposition states. Another area of research involves developing AI systems that can learn from their failures. The future might also bring AI systems that are specifically designed to explore and analyze paradoxes. There is also the possibility that future AI systems might discover new types of paradoxes or find novel solutions to existing ones. However, it is important to recognize that some paradoxes might be fundamental features of logical systems rather than problems to be solved. This suggests that the goal shouldn't necessarily be to eliminate all paradoxes from AI systems, but rather to help them handle paradoxes more gracefully. How we handle paradoxes. To better understand what the ChatGPT crash reveals about artificial intelligence, it's worth examining how humans handle the liar paradox. Unlike AI systems, humans don't crash when confronted with logical contradictions. Instead, we have developed various strategies for dealing with paradoxes that might inform future AI development. Humans can think about their own thinking processes. When we encounter a logical problem, we can recognize that we're encountering a logical problem and adjust our approach accordingly. We can say things like, "This is a paradox," or "This statement is self-contradictory," without becoming trapped in the contradiction itself. The liar paradox isn't just a frustrating logical problem. It's also a fascinating exploration of the nature of truth, language, and reasoning. Humans can appreciate this kind of intellectual beauty even in the face of logical contradiction. When humans encounter the liar paradox, our first reaction is often confusion. We recognize that something strange is happening. When logical reasoning fails, we can turn to intuition, creativity, or other forms of cognition. We can discuss paradoxes with others, share different perspectives, and develop collective approaches to understanding them. The long history of philosophical discussion about the liar paradox demonstrates the value of this social approach to reasoning. Humans can recognize when language is being used in unusual or paradoxical ways and adjust their interpretation accordingly. We can understand that "this statement is false" is a special kind of statement that doesn't follow normal linguistic rules. The discovery of irrational numbers by the ancient Greeks created a crisis in their mathematical worldview. Russell's paradox, discovered by Bertrand Russell, showed that the seemingly simple concept of a set of all sets led to logical contradictions. This paradox, along with others, forced mathematicians to rebuild the foundations of mathematics on more careful logical grounds. They believed that all numbers could be expressed as ratios of integers, but the square root of 2 couldn't be expressed this way. This paradox forced them to expand their understanding of number and quantity. The measurement problem, quantum entanglement, and Schrodinger's famous cat paradox all point to fundamental mysteries in our understanding of the physical world. They arise when our existing conceptual frameworks encounter their limits. They force us to question our basic assumptions about reality, and they often lead to new insights and discoveries. The paradoxes in mathematics led to more sophisticated mathematical frameworks. The paradoxes in physics led to revolutionary new theories. Perhaps the paradoxes in AI will lead to new approaches to artificial intelligence that are more sophisticated and robust. We're not trapped within a single logical framework in the way that current AI systems are. Just as mathematical and scientific paradoxes have revealed the limits of our understanding of numbers and physical reality, the liar paradox reveals the limits of our current approaches to artificial intelligence. But the normal rules of logic seem to be breaking down. But instead of becoming trapped in an infinite loop like ChatGPT, but by developing new approaches to AI that can handle paradoxical reasoning more gracefully. His incompleteness theorems showed that any mathematical system complex enough to include arithmetic would contain statements that couldn't be proven true or false within that system. The paradoxes of quantum mechanics weren't solved by finding classical explanations for quantum phenomena. Instead, they were transcended by developing quantum mechanics as a new framework for understanding reality. The development of quantum mechanics in the early 20th century was driven partly by paradoxes in classical physics. The wave-particle duality of light and matter created apparent contradictions that couldn't be resolved within classical frameworks. These paradoxes forced physicists to develop new ways of thinking about reality. This was a profound limitation that couldn't be overcome by making the system more sophisticated. We have the ability to step back and examine the paradox from a higher level. Creating AI systems that can handle paradoxes more gracefully might require incorporating some of these human-like capabilities. The Michelson-Morley experiment created a paradox by showing that the speed of light appeared to be constant regardless of the observer's motion. This paradox led Einstein to revolutionary insights about the nature of space and time. Metacognition, tolerance for contradiction, cognitive flexibility, and social reasoning. We might find paradoxes frustrating, fascinating, beautiful, or amusing. These emotional responses provide additional information about the nature of the paradox and our relationship to it. They also help us maintain perspective and avoid becoming too trapped in the logical details. We can recognize that this is a problem with the logical system itself, not necessarily a problem that needs to be solved within that system. We can appreciate the paradox as a window into the nature of logic and language. We can understand that the statement "this statement is false" is both true and false in some sense, without needing to resolve that contradiction definitively. It connects to a broader pattern of paradoxes that have shaped the development of science and mathematics throughout history. Understanding this broader context helps us appreciate the significance of the crash and its implications for our understanding of knowledge and reasoning. We can live with ambiguity and uncertainty in ways that current AI systems cannot. This metacognitive ability is crucial. Humans also have the ability to hold contradictory ideas simultaneously without experiencing system failure. This tolerance for contradiction extends to many areas of human experience. We can hold conflicting emotions, maintain beliefs that are somewhat inconsistent, and make decisions based on incomplete information. This flexibility might be seen as a weakness from a strictly logical perspective, but it's actually a strength when dealing with the complexities of real-world reasoning. Humans also have the ability to recognize when logical reasoning has reached its limits. When we encounter a paradox, like the liar paradox, this philosophical perspective allows humans to find meaning and value in paradoxes even when we can't resolve them. Humans also have the ability to switch between different modes of thinking. This cognitive flexibility extends to our use of language. The human response to paradoxes also involves emotional and aesthetic dimensions. Humans also have the social dimension of paradox resolution. All of these human capabilities suggest directions for future AI development. Paradoxes in science and mathematics. The ChatGPT crash isn't just relevant to AI development and philosophy. Mathematics, despite its reputation for logical rigor, has been repeatedly shaken by paradoxes. In the late 19th and early 20th centuries, mathematics faced another crisis with the discovery of paradoxes in set theory. The work of Kurt Gödel in the 1930s revealed even deeper paradoxes in mathematical reasoning. Physics has also been shaped by paradoxes. Einstein's theory of relativity arose from paradoxes in our understanding of space and time. More recently, quantum mechanics has revealed new paradoxes that continue to challenge our understanding of reality. These scientific and mathematical paradoxes share important features with the liar paradox. The ChatGPT crash can be understood as part of this broader pattern. This broader context also suggests that paradoxes shouldn't be seen as problems to be eliminated, but as opportunities for deeper understanding. The history of science and mathematics also suggests that paradoxes are often resolved not by solving them directly, but by developing new frameworks that transcend them. This suggests that the challenges posed by the liar paradox to AI systems might be resolved not by finding better ways to solve the paradox. How a systems process language to fully understand why ChatGPT crashed when confronted with the liar paradox. We need to examine the technical details of how AI systems like ChatGPT actually process language. This isn't just about understanding one particular system, but about understanding the fundamental approaches that underlie most current AI systems. The system learns that certain words tend to follow other words, that certain phrases are common in certain contexts, and that certain grammatical structures are more likely than others. ChatGPT belongs to a class of AI systems called large language models, or LLMs. These systems are trained on vast amounts of text data. It doesn't have a mental model of the world or genuine comprehension of meaning. Instead, it has become incredibly sophisticated at recognizing and reproducing patterns in text. The paradox creates a logical structure that doesn't follow normal patterns. The system determines that if the statement is true, it must be false, so it categorizes it as false. But then it determines that if the statement is false, it must be true, so it categorizes it as true. When the system tries to process the statement, "This statement is false," it attempts to categorize it as either true or false based on its training. The system becomes stuck repeating the same reasoning process without being able to reach a stable conclusion. If the training data doesn't include examples of how to handle paradoxes, the system won't learn effective strategies for dealing with them. This suggests that future AI systems might need to be trained on more diverse data that includes examples of paradoxical reasoning. Not all AI systems are created equal, and different architectures and training approaches might lead to different responses to the liar paradox. Some are trained primarily on text data, while others incorporate other types of information. These systems might be better equipped to recognize and handle paradoxes because they have built-in mechanisms for logical analysis. They might be able to detect when they're encountering a self-referential statement and handle it appropriately. Systems trained on data that includes discussions of paradoxes and logical reasoning might be better equipped to handle these challenges. They might have learned strategies for recognizing and discussing paradoxes without getting trapped in them. These differences can lead to different approaches to handling paradoxes. Larger systems with more parameters and more sophisticated architectures might be better able to handle the complexity of paradoxical reasoning. These systems might be able to recognize when they re-encountering a paradox and switch to a different reasoning mode that is better suited to handling it. They might have more cognitive resources available to handle the challenges posed by self-referential statements. Systems that are designed to have conversations with users might be better equipped to handle paradoxes. For example, some researchers are exploring AI systems that can reason about their own reasoning processes, which might allow them to detect and handle paradoxes more gracefully. Because they can acknowledge the paradox and discuss it with the user, rather than trying to resolve it internally. When confronted with the liar paradox, suggests that this kind of stress testing should be a standard part of AI development. Different systems should be tested with various paradoxes to understand their limitations and capabilities. These systems might be less likely to crash when confronted with paradoxes because they have better safeguards against infinite loops and other failure modes. They might recognize when they're stuck in circular reasoning and break out of it. Examining these differences can provide insights into the nature of AI reasoning and the factors that influence how AI systems handle logical challenges. Sometimes, simpler systems might be more robust because they have fewer ways to fail. A system with limited reasoning capabilities might simply reject paradoxical statements as meaningless rather than trying to process them. In normal programming, infinite loops are prevented by various safeguards and timeout mechanisms. Systems that have been specifically trained to recognize and handle unusual or problematic inputs might be more resilient when confronted with paradoxes. But the liar paradox creates a particularly subtle form of infinite loop that is difficult to detect and prevent. And learn to predict what words or phrases are likely to come next in a sequence. This might sound simple, but it's actually an incredibly sophisticated process that involves complex mathematical operations and massive computational resources. This vector captures the meaning and context of your question in a way that the AI system can work with. Memory fills up with repeated attempts to resolve the paradox. Processing power is wasted on circular reasoning. Eventually, the system becomes unable to function normally and crashes. It can recognize the type of question being asked and generate an appropriate response based on the patterns it has learned. They're designed to process information and generate responses based on learned patterns. They're not designed to handle logical contradictions or paradoxes that don't fit these patterns. The system then uses this vector to generate a response by predicting what words are most likely to follow given the context. The training process involves feeding the AI system millions of examples of text and teaching it to recognize patterns in language. When you ask ChatGPT a question, it processes your input by converting it into a mathematical representation called a vector. This process involves multiple layers of neural networks, each of which performs different types of pattern recognition and transformation. The entire process happens very quickly, but it involves billions of mathematical operations and comparisons. The key insight is that ChatGPT doesn't actually understand language in the way humans do. When ChatGPT encounters a normal question or statement, it can process it effectively because it has seen similar patterns during training. But the liar paradox presents a unique challenge to this pattern-based approach. However, the paradoxical nature of the statement means that any attempt to categorize it leads to a contradiction. This creates what computer scientists call an infinite loop. The system's resources become consumed by this repetitive reasoning process. This crash reveals something fundamental about the architecture of current AI systems. The crash also reveals the importance of the training data used to create AI systems. How different models handle paradoxes. The ChatGPT crash raises interesting questions about how different AI systems handle paradoxes. Different AI systems have different architectures and training methodologies. Some are based on transformer architectures like ChatGPT, while others use different neural network designs. For example, some AI systems are designed with explicit logical reasoning capabilities. Other AI systems are designed with more robust error handling and recovery mechanisms. The training data used to create AI systems also plays a crucial role in how they handle paradoxes. The size and complexity of AI systems also matter. However, size and complexity aren't always advantages when it comes to handling paradoxes. The specific prompt engineering and fine-tuning used to prepare AI systems for deployment also influence how they handle paradoxes. Some AI systems are designed with multiple reasoning modules that can handle different types of problems. The user interface and interaction design of AI systems also play a role. Research into different AI architectures continues to evolve, and new approaches are being developed that might be better suited to handling paradoxes. The comparison between different AI systems also reveals the importance of testing and evaluation. The fact that ChatGPT crashed. What this tells us about mind and consciousness. The ChatGPT crash, when confronted with the liar paradox, raises profound philosophical questions about the nature of mind, consciousness, and intelligence. These questions extend far beyond the technical details of AI systems to touch on fundamental issues in philosophy of mind and cognitive science. Humans can encounter the liar paradox, and while we might be confused or puzzled, we don't crash. We can recognize it as a paradox, discuss its implications, and continue functioning. Some philosophers argue that consciousness involves the ability to be aware of one's own mental states and processes. This self-awareness is inherently self-referential, similar to the self-reference in the liar paradox. Does it genuinely understand the question and its answer? The liar paradox challenges our basic concepts of truth and falsehood. That any sufficiently complex formal system will contain statements that can be proven true or false within that system. The ChatGPT crash might be seen as a practical demonstration of these theoretical limits. The fact that it can crash an AI system suggests that these concepts might be more complex and problematic than we typically assume. Perhaps genuine intelligence requires something beyond mechanical symbol manipulation, something that can't be captured in formal logical systems. Perhaps our ordinary notions of truth and falsehood break down when applied to self-referential statements. Understanding these practical applications helps us appreciate legal precedents might contradict each other, laws might contain internal contradictions, and evidence might point in multiple directions simultaneously. An AI system used for legal analysis needs to be able to handle these contradictions without crashing or becoming trapped in infinite loops. Why the ability to handle paradoxes isn't just an academic curiosity, but a crucial capability for AI systems that operate in complex real-world environments, or legal precedents that seem to contradict each other. If the system crashes when confronted with these contradictions, it would be useless for real-world legal analysis. People use language in creative and sometimes contradictory ways. It might crash when encountering a joke that plays with logical contradictions, or when processing a text that contains self-referential statements. They make statements that are ambiguous, use sarcasm and irony, and sometimes say things that don't make perfect logical sense. An AI tutoring system needs to be able to handle these contradictions without crashing. It needs to be able to recognize when a student is expressing contradictory ideas and help them work through the logical challenges. Symptoms might be consistent with multiple diseases, test results might be contradictory, and medical knowledge itself might contain uncertainties and contradictions. And financial models might generate conflicting predictions. Art, literature, and music often involve paradoxes and contradictions. An AI system used for creative applications needs to be able to handle these logical challenges without becoming trapped in infinite loops. An AI system used for financial analysis needs to be able to process this contradictory information and provide useful insights despite the logical challenges. Scientific data often contains contradictions and anomalies that need to be resolved. An AI system that crashes when confronted with contradictory data would be useless for scientific analysis. It's a fundamental requirement for any AI system that needs to operate in complex, real-world environments. We need to test AI systems with challenging, logical problems to understand their limitations. We need to develop better approaches to handling contradictions and paradoxes. And we need to be careful about deploying AI systems in applications where their inability to handle paradoxes could cause problems. The ChatGPT crash demonstrates that current AI systems have significant limitations in this regard. An AI system used for medical diagnosis needs to be able to handle these ambiguities without becoming paralyzed by logical contradictions. Instead, it needs to be able to recognize the contradictions, analyze their implications, and provide useful guidance despite the logical challenges. Then why don't AI systems display the same kind of flexibility in handling paradoxes that conscious beings do? This might suggest that consciousness involves something beyond computation, or that current AI systems are missing some crucial computational component. Or is it simply manipulating symbols according to learned patterns? The crash suggests that whatever understanding ChatGPT has is fundamentally different from human understanding. Perhaps the ability to handle self-referential paradoxes is connected to the capacity for self-consciousness. Does this suggest that consciousness involves some kind of metacognitive ability that allows us to step outside our own reasoning processes? One of the most intriguing questions is whether the ability to handle paradoxes is a necessary component of genuine intelligence or consciousness. The crash also raises questions about the relationship between intelligence and logical consistency. Traditional approaches to AI have emphasized logical consistency, and formal reasoning. The ChatGPT crash isn't just a technical problem to be solved. It's a window into fundamental questions about the nature of mind, intelligence, and consciousness. But the human response to paradoxes suggests that genuine intelligence might actually require the ability to handle inconsistency and contradiction. Perhaps the flexibility to live with paradoxes is more important than the ability to resolve them. This connects to broader questions about the nature of consciousness. The crash also illuminates the difference between behavioral intelligence and genuine understanding. ChatGPT can engage in sophisticated conversations, answer complex questions, and generate creative content. But when confronted with a fundamental logical challenge, it crashes. This suggests that there might be important differences between appearing intelligent and actually being intelligent. This raises questions about what we mean by understanding. When ChatGPT generates a response to a question, the philosophical implications extend to questions about the nature of truth and meaning. The crash also connects to questions about the limits of formal systems and mechanical reasoning. The mathematician Kirk Dell showed this suggests that there might be fundamental limitations to what can be achieved through purely computational approaches to intelligence. The crash also raises questions about the relationship between mind and computation. If AI systems are computational systems, and if consciousness is somehow based on computation, these philosophical questions don't have easy answers, but they're important to consider as we develop more sophisticated AI systems. Why this matters beyond philosophy, while the ChatGPT crash might seem like an abstract philosophical problem, it has important real-world implications for how we develop and deploy AI systems. In legal reasoning, lawyers and judges regularly encounter situations that resemble logical paradoxes. Consider a situation where an AI system is analyzing contract law. It might encounter a contract that contains contradictory clauses. Medical diagnosis presents similar challenges. Financial analysis is another area where paradoxes and contradictions are common. Market conditions might send contradictory signals. Economic indicators might point in different directions. The problem extends to any AI system that needs to process natural language because natural language is full of ambiguities, contradictions, and paradoxes. An AI system that crashes when confronted with logical paradoxes would be unreliable for processing natural language in real-world contexts. The implications extend to AI systems used in education. Students often have misconceptions and hold contradictory beliefs. In scientific research, AI systems are increasingly being used to analyze data and generate hypotheses. The problem also extends to AI systems used in creative applications. These real-world applications suggest that the ability to handle paradoxes isn't just a nice-to-have feature for AI systems. This has practical implications for how we develop and deploy AI systems. Future directions for AI research. The ChatGPT crash when confronted with the liar paradox points to several important directions for future AI research. These directions involve both technical challenges and fundamental questions about the nature of intelligence and reasoning. These systems would be able to monitor their own reasoning processes and detect when they re-encountering logical problems. Current AI systems are designed to process information and generate responses, but they don't have sophisticated mechanisms for monitoring their own reasoning processes. These systems would be designed to operate effectively even when confronted with conflicting information or logical contradictions. Instead, AI systems need to be designed around logical frameworks that can handle contradiction and uncertainty. Current AI systems are trained primarily on text data that follows conventional logical patterns. AI systems trained on these datasets might be better equipped to handle the liar paradox and similar challenges. They might use formal logical reasoning for some problems, probabilistic reasoning for others, and heuristic approaches for still others. Training AI systems on data that includes paradoxes, contradictions, and other logical challenges might help them develop better strategies for handling these problems. The system could switch to another method that's better suited to the problem at hand. Current machine learning approaches are primarily designed to learn from positive examples and successful outcomes. This might involve drawing on recent work in non-classical logics. A system that crashes when confronted with a paradox might be current AI systems are primarily based on neural networks and statistical learning. What does this crash tell us about the nature of intelligence, both artificial and human? What broader lessons can we draw from this encounter between ancient philosophy and modern technology? These approaches might offer different capabilities and limitations when it comes to handling paradoxes. ChatGPT can process vast amounts of information, recognize complex patterns, and generate sophisticated responses. It might require the kind of cognitive flexibility that allows humans to encounter the liar paradox and continue functioning despite its logical challenges. But when confronted with a fundamental logical challenge, it fails in a way that reveals the limitations of its underlying approach. But they do and have sophisticated mechanisms for monitoring their own reasoning processes or recognizing when they re-encountering logical problems. The same paradox that puzzled ancient Greek philosophers proved capable of crashing a 21st century AI system. It may not be able to eliminate the fundamental challenges that paradoxes represent. This suggests that some challenges to reasoning are fundamental and persistent, transcending specific technologies or approaches. But there might be other approaches to AI that are suited to handling paradoxes and logical challenges. Traditional approaches to AI have emphasized logical consistency and formal reasoning. AI systems are incredibly powerful, but they're not omniscient or infallible. They have specific capabilities and specific limitations. As we create more sophisticated AI systems, you need to grapple with fundamental questions about the nature of intelligence, consciousness, and reasoning. The liar paradox serves as a valuable test case for these questions. The liar paradox isn't just an abstract philosophical puzzle. The insights of centuries of philosophical thinking about paradoxes, logic, and reasoning can inform the development of more sophisticated and robust AI systems. It is a practical test of reasoning capabilities that can reveal important truths about AI systems and their limitations. Understanding these limitations is crucial for using AI systems effectively and responsibly. But the human response to paradoxes suggests that genuine intelligence might actually require the ability to handle inconsistency and contradiction, designed to learn from that experience and develop better strategies for handling similar challenges in the future. We can step outside our own reasoning processes and examine them from a higher level. This metacognitive ability might be a crucial component of genuine intelligence. It shows us how far we've come in creating intelligent machines, but it also shows us how far we still have to go, such as paraconsistent logics that can handle contradictions without collapsing. Rather, it suggests that intelligence might require a more flexible and nuanced approach to logic than current AI systems possess. It might require the ability to recognize when logical frameworks are breaking down and to adapt accordingly. They might be able to hold multiple conflicting beliefs simultaneously, or to make decisions based on incomplete or contradictory information. Developing these capabilities would require new approaches to AI design that incorporate multiple levels of reasoning and self-monitoring. When a paradox is detected, the system could switch to a different mode of operation, perhaps acknowledging the paradox and discussing its implications rather than trying to resolve it. Understanding these future directions helps us appreciate the significance of the crash and its implications for the development of AI systems. One important direction is the development of AI systems with better metacognitive capabilities. This kind of metacognitive capability would require significant advances in AI architecture. Another important direction is the development of AI systems that can handle uncertainty and contradiction more gracefully. This approach would require moving beyond traditional logical frameworks that assume consistency and completeness. The development of more robust training methodologies is another important direction. This might involve creating specialized training datasets that include examples of paradoxical reasoning, logical contradictions, and other challenging logical problems. The integration of different reasoning approaches is another promising direction. Instead of relying on a single approach to reasoning, future AI systems might integrate multiple reasoning methods. This kind of hybrid approach might be more robust when confronted with paradoxes. If one reasoning method fails, the development of AI systems that can learn from their failures is another important direction. This would require advances in machine learning that allow AI systems to learn from negative examples and failure modes. The exploration of alternative approaches to AI is another important direction. This might involve exploring approaches based on symbolic reasoning, quantum computing, or other alternative paradigms. What the crash reveals about intelligence. As we reach the end of our exploration of the ChatGPT crash and the liar paradox, it's worth stepping back to consider the bigger picture. The crash reveals something fundamental about the difference between intelligence and mere information processing. This suggests that genuine intelligence might require more than just sophisticated information processing. It might require the ability to handle contradiction, ambiguity, and paradox. The crash also reveals the importance of self-awareness and metacognition in intelligence. Humans can encounter paradoxes and recognize them as paradoxes. Current AI systems like ChatGPT lack this kind of metacognitive capability. They process information and generate responses. The crash also illuminates the relationship between intelligence and logical consistency. This doesn't mean that logic is unimportant. The crash also reveals the persistence of certain fundamental challenges in reasoning. This should make us humble about our ability to solve all logical problems through technology. While technology can provide new tools for thinking about these problems, the crash also highlights the importance of understanding the limitations of our tools. Finally, the crash reveals the value of philosophical thinking in understanding technology. This suggests that the development of AI systems should involve not just technical expertise, but also philosophical reflection. The crash also raises important questions about the future of AI development. Ultimately, the ChatGPT crash, when confronted with the liar paradox, reveals both the remarkable capabilities and the fundamental limitations of current AI systems. The eternal dance between mind and paradox. As we conclude our journey through the fascinating intersection of ancient philosophy and modern technology, we find ourselves with more questions than answers. The ChatGPT crash, when confronted with the liar paradox, isn't just a technical curiosity. It's a window into the fundamental nature of intelligence, reasoning. This statement is false can trace a line from ancient Greece to the cutting edge of artificial intelligence. We've explored how this paradox has puzzled philosophers for millennia and how it continues to challenge our most sophisticated technological achievements. We've witnessed the moment when silicon met ancient wisdom and found itself wanting. We need to remember that the deepest questions about intelligence, consciousness, and reasoning aren't just technical problems to be solved. Connecting the insights of Greek philosophers with the challenges of contemporary AI development, it reminds us that some questions transcend specific technologies or historical periods. They touch on the fundamental nature of truth, meaning, and rational thought. In an age of rapid technological change, it's easy to assume that ancient philosophical problems are irrelevant to modern concerns. But the ChatGPT crash demonstrates that the insights of philosophers like Epimenides, Chrysippus, and Russell remain crucially relevant to our understanding of intelligence and reasoning. They're fundamental aspects of existence that require careful philosophical reflection. The lessons of the ChatGPT crash should guide our efforts. It continues today as we grapple with the limitations of our artificial creations. and it will persist as long as conscious beings seek to understand the mysteries of their own existence. It showed us that some questions transcend time and technology, challenging every generation to grapple with the fundamental nature of truth, meaning, and rational thought. And perhaps that's the most important lesson of all, that the quest to understand intelligence, whether human or artificial, is itself an endless and endlessly fascinating journey into the deepest mysteries of existence. We need to create AI systems that can handle not just the clean, consistent patterns of formal logic. It reminds us that the deepest questions aren't always the ones with the clearest answers. Sometimes, the most profound insights come from recognizing the limits of our understanding and finding meaning in the very impossibility of certain logical structures, but also the messy, contradictory, and paradoxical nature of real-world reasoning. We need systems that can recognize their own limitations and operate gracefully within them, and the persistent mysteries that challenge both human and artificial minds. Our AI systems still struggle with the same fundamental logical challenges that have puzzled humans for thousands of years. It's about understanding the nature of intelligence itself. Every limitation we discover in AI systems teaches us something about the nature of mind, consciousness, and rational thought. We would do well to remember the lessons of this ancient paradox. Intelligence isn't just about processing information or recognizing patterns. It is about navigating the fundamental contradictions and paradoxes that arise when minds turn their attention to themselves and to the nature of truth itself. This isn't a failure of technology. It is a revelation of the deep complexity inherent in rational thought itself. It represents something fundamental about the nature of self-reference, truth, and logical reasoning. While we may develop AI systems that can handle it more gracefully, the paradox itself will remain as a persistent reminder of the mysteries that lie at the heart of rational thought. We've seen how a simple statement, the crash, reveals something profound about the current state of AI technology. Despite remarkable advances in pattern recognition, language processing, and information synthesis, but perhaps the most important lesson from this encounter is about the nature of intelligence itself. The fact that humans can encounter the liar paradox and continue functioning and recognize it as a paradox, discuss its implications, and find meaning in its very impossibility suggests that intelligence is more than just logical processing. It's the ability to navigate contradiction, to live with ambiguity, and to find beauty in the breakdown of formal systems. The crash also reminds us of the importance of philosophical thinking in our technological age. As we create increasingly sophisticated AI systems, the liar paradox serves as a bridge between the ancient world and the modern age. As we move forward in developing artificial intelligence, the crash also highlights the ongoing relevance of philosophical inquiry. Perhaps most importantly, the crash reminds us that the pursuit of artificial intelligence isn't just about creating useful tools. The liar paradox will likely continue to challenge both human and artificial minds for generations to come. As we continue to push the boundaries of artificial intelligence, the dance between mind and paradox is eternal. It began with the first philosophers who wondered about the nature of truth and reasoning. In the end, the ChatGPT crash, when confronted with the liar paradox, tells you something beautiful about the nature of intelligence and reasoning. The liar paradox crashed an AI system, but it also illuminated the remarkable journey from ancient philosophy to modern technology.